afternoon. This is Lorena, host of Evolution Greenworks, and I'm here today with Don Walker. And Don Walker is with Kynetic Energy, and they're doing some really exciting things with hybrid solutions for off-grid applications and storage. I'm going to turn it over to Don. Don, can you tell us a little bit about what Kynetic Energy is doing?
What we're doing is we're trying to, we have a patented vertical axis wind turbine that we're using to target the off-grid remote communication tower sites, which are basically generated power from their diesel generated operation. So we're trying to reduce or eventually eliminate that.
Excellent. So are you creating like a microgrid then? So you're storing the energy and then they use it as they need it?
Right now, all of these remote communication towers, and surprisingly enough, there's about 1.2 million of them throughout the world. And most of them are being powered by diesel generators, and it's very expensive. It pollutes the atmosphere, but they have their own little self-contained operation. They have old battery technology. They have 1 or 2 diesel generators on their sites, and that's how they produce the power to operate these communication towers.
Well, that's interesting. So when you talk about they're saving diesel and they're saving the environment here, what kind of cost savings would that be? Like, what would the return for investment for something like that if you had to run an operation like that on diesel?
Well, that's unfortunately that's the most difficult information to gather. We've got studies that show that the cost, when you factor in the cost of replacing the diesel generator every 3 to 5 years and having a spare diesel generator there in case the one that you have operating goes down, and the replacing of the batteries every 4 to 5 years as well. When you factor in all that and the delivery of the diesel to the sites, some of these sites are only winter road access, so you've got you've got 6 weeks in the wintertime to get up there and drop off your fuel. So when you factor all of these in, it can be like $5 a kilowatt hour, which is it's crazy. Yeah, and so it's virtually impossible to operate that.
I guess adding the environmental impact to that too, because then you've got like diesel spillage. You got trucks that don't make it up there, so you likely have trucks in the in the lakes on winter roads, right?
These are average costs. So of course, some years it might be a little bit lower, but others could be significantly higher because, like you said, there's lots of variables in that type of operation, and until now there hasn't been any option for them.
Right. So creating these microgrids where they can use their power and then they can also store their energy and have everything right there. First, I would like to talk a little bit about your turbine technology, because it's a VAWT, right? A VAWT, which is a vertical axis turbine.
Very good.
But not everybody knows what that is and what the advantages are for that kind of a turbine. Did you want to talk about your technology?
Well, it's a vertical axis wind turbine, like you said. So it's not like the big wind farms that you see. Those are horizontal axis wind turbines, and they take up a lot of space. They're built to power into grids. Ours is to basically target the off-grid power needs of either communities or businesses such as communication towers. So the technology is virtually the same, except ours operates a little bit differently in that it takes the wind from any direction. So the blades move in a roundabout way. So it doesn't matter which way the wind is coming from, it'll power our generator. So that's one thing. And of course, there's been all this about killing birds with the horizontal axis wind turbines. So we don't have those kind of issues, although I don't think it's not much of an issue on the horizontal ones any longer anyways. But so that's the basic difference, is that it's a smaller space. It takes up a smaller space because of the way the blades are positioned, and it can virtually go anywhere.
How high up does a turbine typically need to be?
Well, it has to catch the wind. So it all depends on the environment in the area where you are. So if you're in the middle of if you're in a farmer's field where you've got no trees to slow down the wind, then you could be as high as maybe 30 feet, 10 meters up. But if you've got other impediments to the wind there, then you could go as high as 90 feet, depending on the circumstances. So it all depends on the area that you're putting up.
So the smoother the air, the better, basically, like.
Well, it's if you're in the middle of a bush, you're going to have to get over those trees, and the higher, the more north you go, the lower the trees are. But if you're trying to get the maximum wind in the southern part of Canada, for instance, you may have to go 60, 90 feet, depending on where you want to locate it.
Right. Yeah, that makes sense. Like here in Manitoba, southern Manitoba, what would that average be if there was no trees? Like, what kind of wind speed would we see?
Oh, well, that's, again, it's it's variable, right? So when a potential customer contacts us and wants to look at putting a turbine up in their area, and we put up several in Saskatchewan on farmers locations where the Saskatchewan government had a program to sell the excess power to their grid, and we've gone and in some fields where there's no trees in the way, that it can go as high as only 30 feet. So that's a benefit. But depending on how far you are from where the power is needed, right, to connect into your grid, if you put it in the middle of a farmer's field and you still have to run lines to the grid, then it might be more economical to put it up closer to the grid.
Well, just for our viewers, because they are very different, these vertical access turbines, we actually have a video clip that we're going to run right away here for Don, and we're going to get a real close look at what these vertical turbines from Kynetic Energy look like. Again, they're 5 kilowatt, right, Don?
Yep.
Excellent. And what does a 5 kilowatt produce in a year, roughly? Like, I mean, just averages, of course.
Well, depending again on the wind conditions in your area, it can go from we try and target a sweet spot of maybe 8 meters per second for wind speed on average. So that'll produce 10,000 kilowatts in a year.
Nice. Okay. And that would be an average gas heat home, right? So anywhere from 8 to 10,000 kilowatt hours a year is the average gas heat home for like a 1,200 square foot home.
There you go.
Solar designer. All right, let's run that clip for you, Don. I'm pretty excited to show everybody what your turbine looks like. It's very sleek. Here we go. Wow, so it's pretty sleek looking. I really like the look of that. And I think what's really interesting here, and I think we're going to talk a little bit more about your entire package for the way you guys are moving forward into, it looked like you, on your website anyways, that you were going into like Army kind of stuff and mines, and so a lot of remote applications. So if you want to fill us in about how that is.
Well, the technology is virtually the same. So we have a vertical axis wind turbine. We use solar, the latest, well, hopefully the latest solar technology. There's been improvements every year, it seems, in that area, as well as the, I don't call them batteries anymore. I call them power storage devices, because they're coming with all kinds of designs in that technology. So we take the three of them, because you don't get sun all the time, you don't get wind all the time. So we put together what is a bit of a hybrid solution, storing the power for when it's needed for the customer. Now we were also asked to look at if we can make a mobile version of those basically three technologies. So we were asked to partner with Arnie's Welding in Winnipeg, who's unbeknownst to us at the time is an approved military supplier. They produce trailers for the military, so they have the technology and the know-how to produce a platform that we can put our vertical axis wind turbines and solar panels and power storage devices, and we could even put a small little diesel generator on there just in case, or depending on what the environment in there that this is going to be used in. So we've got the three sources of power and the storage device on a platform that can go and help the firefighters or the flood victims when their grid goes down. We can, hopefully provide power to help them get to restoring their grid.
Yeah, I was looking at the video for this is just truly amazing. The way it kind of just all unfolds almost like a flower. So I'd really like to share that also with the viewers today. So I'm going to run that video right now. But just before I do, one of the things that I really liked is how compact. I know it's on a big trailer, but it's producing a lot of power, right? I mean, you've got 10 kilowatts of wind, so 2 5-kilowatt turbines, and then you have 10 kilowatts of solar, and then you have 50 kilowatts of storage. Now, that 50 kilowatts of storage, is that the usable capacity of the storage, or is that the total capacity of the storage?
Usable.
Usable? Okay,
Yeah.
great. And is that like in 240 volt, 120, or is that just 120 volt power that it's providing to the facility?
Oh, you're getting out of my expertise there.
Oh, no.
That's like debits and credits to an accountant.
And it's
So,
probably changeable too, right? So
yeah,
depending on what inverter you use.
exactly. So we use all types of inverters that, depending on what the power requirement is.
Perfect. Well, I'm going to run that video for everybody to see right now. It was truly phenomenal.
Did I lose you?
There we go.
No.
We're back. We're back. That was quite exciting. I love how it just folds right out. So it compacts right down so it can get right to all these disaster sites as needed.
Yeah, originally we were asked to participate in a military program where they were looking for mobile power to accompany their camps as they move from site to site. So they asked us to see if we could design something, and we made a presentation in Ottawa last January, actually, with the Canadian government, and was well received. Unfortunately, we had some circumstances that sort of put everything on hold for the last 10 months, and so we're waiting to hear what they want to do for next steps on that. But it can be used in several different environments, and the wildfires and the flooding that's going on. Basically, it's the same problem that we're trying to solve.
Absolutely. I can see how this really can fill in the gaps for even some companies. You want to talk about direct marketing to mines and northern kind of spaces?
Well, the mines may not. Mines are usually they don't move around. So we could put our vertical axis wind turbine in the mines to provide the power that they require. However, the MPPT, as we call it, the mobile power plant trailer, could be used as they're building the mines, as they're developing the mines. But once the mine is up and running, then a more permanent power solution would probably be in. So a number of our 5 kilowatt vertical axis wind turbines would be a better solution on the long term.
Excellent. I love the play on that. So you call it an MPPT?
Yeah.
Mobile power plant trailer, and that is the technology that's utilized in the solar technology side and probably the wind side as well, right? They take the higher voltage and then they bring it out and reduce it down to the battery voltage. So that's called maximum power point tracking. So I think that's kind of cute that you're using it.
I don't know. Yeah, I don't know who got the acronym first.
Well, it's cute because it's utilizing that technology, right? So, right. Just for those of you, I've got 12 years in the industry, so I thought that was cute as soon as you said it. So, where do you see Kinetic going from here? Like you just mentioned a few challenges with COVID. A lot of companies are facing that right now. How are you guys marketing or strategizing through the pandemic?
Well, we still are talking to our targeted market, which are the telecommunication companies, and but during this during this COVID period, we've actually been able to take this sort of down period and really work on our R&D. So what we're trying to do right now is make it more efficient, make the turbine more efficient, more reliable. So we're looking at all the points of failure to see if they can be improved upon. We're actually making great strides in the efficiency. So instead of trying to maximize power at 50 kilometer an hour winds, we're trying to get power being generated at 10 kilometer winds, so that it just has a bigger appeal, a larger appeal to various markets. So that's what we've been doing for the last 6 months now.
Well, that's excellent. So you're working on the efficiency and the overall product so that it's more ready for whatever it is you need to roll it out into?
Correct. We have a product right now that's ready for market for the communication towers. The communication towers don't take a lot of power as you might think. So we've already got something that addresses that right now. But we always want to be better. We want to make it more efficient, and that's what we've been working on.
Well, that's really good stuff. And how long have you been doing this? Like, is this something you guys have been working on? Like, the rollout of this particular unit? Like, is this like a company? Is this coming to your dream, the goal to have transportable, like, power stations, basically?
Well, that's the next step, is working with our partners to bring that to market. Right now it's a concept. Right, it's in development. It's very doable. We've been working with Arnie's Welding on the platforms that they've been producing for other needs of the military, and it's just a matter of designing the right parameters to fit our devices, and we have the technology. It's just a matter of fitting everything in and making sure that it works efficiently and delivers what we promise.
Yes, well, everybody starts with a concept somewhere. I really love the design. It's very sleek. The way, like I said, it just unfolds and it's ready to go. And it looks like very heavy duty too, what the plan is, so that it can go into virtually any kind of scenario, whether it be a wildfire scenario or anything like that, right?
Yeah, the military program that we were addressing required a ruggedized trailer. So that's where Arnie's Welding specializes in. They build. It's really quite amazing when we met with them. The requirements of the trailer. It's they have to have it designed in such a way that if there's a flat tire, that it can be changed within 30 minutes maximum.
Ooh.
Because they could be up in the Arctic and 35 minutes and the guy may be frozen. So they're so they have the expertise to design it for whatever needs that our customers might have.
Excellent. So if residential customers or farms are interested in the technology that you are producing, whether it be the hybrid, but more of a, I guess, physical, it's their kind of model, or the turbines themselves, what are they looking at for like a return for investment here in Manitoba?
That again depends. Depends on the amount of wind that's in their area. So before we sell it to anyone, what we do is we require their latitude and longitude coordinates so that we can see what their historical wind speeds have been, and will be. And based on that, we determine whether they have enough wind to make this viable or not. We can't compete with Manitoba Hydro, for instance. Manitoba Hydro is 8 cents a kilowatt. No one's going to be able to compete with that. What we're doing is we're trying to, like I said, we're trying to address the off-grid, the diesel-generated ones that are much more expensive, and or even customers that are close to our grid but need to bring the power into whatever their environment is, because that can be very expensive too. If you have to run, 5 or 6 kilometers of telephone poles and wires into your area that you're trying to bring power, and that's, we can certainly address that cost too. So it all depends on that, on the environment that they're in. So for a farmer, it might be closer to the 8 to 10 year mark before they can get return on investment. But if you're a remote diesel generated telco tower, it might be more like 3 years.
Right. And right now, like solar is only about 7 cents a kilowatt cost a plant to put in. So with Manitoba Hydro, they're at 9 cents a kilowatt hour, actually. And they're going up another 2.9% in December 1st to 2020, I believe is what the final amount was. So we're probably going to get into 10 cents a kilowatt pretty quickly, I think, by spring anyway, for Manitoba Hydro. So solar is already cheaper than hydro. So I suspect that the turbine situation also is going to be coming close to par soon too, except for it produces more energy than solar. Like it does it differently. And I think it's always great for the viewers to understand why you're interested in coupling the two, solar and wind, together. And truly, when the sun is shining, usually the wind is not blowing, and when the wind is blowing, the sun is not shining. So it's kind of nice to blend the two technologies together.
Our company is actually called Kynetic Energy Solutions, right? So we provide a solution, and depending on the customer's needs and where they're located, some places solar isn't viable because you only get 4 to 6 hours of sunlight and maybe only 8 months of the year, kind of thing. So you're right. We need both. We need both technologies.
Absolutely, and you've done that nicely, blending your solutions. Anybody wants to go see kineticenergy.com. On the site, you'll be able to see the concepts and also some of the ones that they've rolled out. They've got the great information there. We have below scrolling info at kineticenergy.com as well, and the phone number to call, but you can always just go to their website and check them out. So I would love to thank you, John, for coming on today and telling us all about your company. And is there any parting words you have for us?
No, I don't think so. It's we have our own test site in St. Malo, Manitoba. And it's not very far from the city. So if people want to come and see exactly what it looks like, what it's doing, and ask us direct questions, we're more than willing to sit down with anyone. That's the reason why we set it up that way. And in fact, we even built our own wind tunnel so that we can actually monitor and the improvements that we're making and
so you can see the back drag. So if you make a change with the blade structure,
everything.
You can see that.
Yeah.
That's wonderful.
So from the website, from what you saw on the video, that's our test site. That is real life environmental conditions. But we also have, just adjacent to that, we have an enclosed wind tunnel that we can make small improvements and measure the difference and see whether it's it's creating the results we're anticipating.
Wow, that's very cool. So anybody can come out and check you guys out. So
Yep.
give them a call down in St. Malo. So that's really close to Winnipeg, only about an hour out. And you can check out their, it's a blended design. Do you have the turbine and the solar there? Or?
Yeah, well, you saw in the video. We
Oh,
have,
okay. So that is it. Okay.
Yeah,
Perfect.
and that's a communication tower there. So we have a communication tower, we have our vertical access wind tower, and a 5 or 10, not sure, 5 or 10 kilowatt solar system there. And we have all of the measuring devices. We work with Red River College. They're going to come down and validate our measurements that we're producing, so that eventually on our website we're going to be publishing the power, the wind speeds that are being used to generate this power, so that customers can see exactly what's being produced in real time.
That's phenomenal. So working together with Red River Community College,
Yeah.
you're able to get a little bit more on the scientific side, like for, you know, sharing it with the public and eventually.
Well,
And that,
yeah, they've actually
great.
they've designed a base for us, so that's when we're looking at installations in the tundra, where it's very expensive to bring in either concrete or pile drivers or whatever. So we're looking at different types of bases that we can use so we can produce that. And they've done some blade designs for us so that they're more efficient. So yeah, we've been working quite closely with Red River College.
Well, that's excellent. It was really lovely having you on the show today. Thank you so much, Don, for sharing everything about Kinetic Energy Solutions.
Thank you very much, Mary.
Thank you.